All right, here we go. 6.1 comes after 6.6. Okay, operations of functions. You're also going to hear this as ops, okay, or ops of function. It is not ops as in your enemies. Okay, it is not ops as in black ops. It is ops as in operations. What are the operations of mathematics? Addition. Whoa, we got one. Subtraction. Division. There we go. Those are the operations of mathematics. All we are doing today is these operations with functions. Okay? Today is going to look a lot more complicated than it really is. Okay? I'm serious. It's going to look a lot more difficult than it really is. Most of what we are doing today is like distribution, combining like terms, and then substituting for a variable. Like when you boil it all down. Okay? But because it's in function notation and we have f of x and g of x and we're going to do things with those and they look all crazy, it can be kind of like overwhelming looking, but it's not. All right? So we're going to start out with these two. This is the top of your note sheet. If we have f of x equals 3x and g of x equals 2x minus 1, what it would happen if these two functions like were to be added together? What do you think? If we took the function of x, f of x, and added it to g of x, what would we end up with? F of x includes how many x's? 3x, right? Okay. G of x includes how many x's? 2. So if we put them together, how many do we have? 5x. Are there any constants to combine? Not on the f of x, right? Just the g of x. So we would end up with 5x minus 4. That's all it is. We just combine like terms, right? So that's what we're going to start with here. I forgot to clear my pages. So, there we go. I want you to start by adding in the middle column. Okay, which just kind of defines how we're going to do this and how it's going to look. So it's going to look like the first part. It's going to be f plus g of x. And what we're actually going to do is we're going to take the f of x and we're going to add it to the g of x. I'm going to use a bit of a color coding system today throughout the notes. F of x is going to be represented with red, g of x is going to be green, and then I'll use blue once we combine them. Okay, so now we're going to add these together. So I'm going to take f of x, which f of x is just 3x, right? So I'm going to do 3x. There's my f of x. And then we're adding, right? So I'm going to do plus. And then my g of x is green. So that's 2x minus 4. So all I did was take what's highlighted above, the equation part, and just add it together. So now like we said in the kind of warm-up section, 3x plus 2x gives me 5x and then minus 4. And that's what we end up with is 5x minus 4. One thing that I did not do on the addition one that you're going to see me do on subtraction, and it would probably be a good thing to do, is put these in parentheses. And the next one will explain why. All right, so I'm going to do the same thing. There's 3x, but now this time I'm going to put a minus between. And here's why I want you to make sure you put this in parentheses. That subtraction that's right there in the middle needs to apply to both of these. So 3x, and then it's going to be minus 2x, right? So I've got 3x minus 2x. But now when I distribute that negative, it's a negative times a negative 4. That's going to give me a what? That's going to give me a plus 4. We good with that, where we got that positive 4? Now when I combine like terms, 3x minus 2x is x, and then I don't have anything else to combine with the 4. So it's just x plus 4. how we feel about addition and subtraction. Feeling okay? All right, now we're going to talk about the other two operations, multiplication and division. I'll give you some time to copy down that middle column. All right, when we multiply, we're really just going to do the same thing, but now I'm going to put both of these in parentheses. And I'm not going to put any operation in between them. I'm just going to squeeze them together. Because when we squeeze two things together, what operation is it? Multiplication. Okay. Now, this what we have right here, this 3x times 2x minus 4, this is the same as if it was 3 times x minus 4. What would we do with that 3? We would distribute it, right? Like this. So I've got to do the same thing. I just have to distribute the x along with it. So when I do this, 3x times 2x, what's 3 times 2? 6, but then I also have to do x times x, which is x squared. Then I distribute to the negative 4, so it's going to be minus 3 times 4 is 12, and then I still have an x. Bingo. Now for division, I'm going to take my 3x, and I'm going to put it on top, and then I'm going to take my 2x minus 4 and put it on the bottom. Now in this case, there's no need for me to factor out and simplify, but there may be some cases where we can. Like if that 3x was actually a 4x, okay? Then I could factor a 2 out of the bottom, and then the 4 and the 2 I could simplify, but we're not going to worry about that right now. Here's the only catch with division. I want you to highlight this, star this, right there. G of x, which is in the denominator, cannot be 0. We cannot have 0 on the bottom of a fraction. Really from here on out. If you have 0 on the bottom, or not 0, if you have a variable on the bottom of a fraction in the denominator, you're going to have to find what's called excluded values. X cannot be what? And the way you figure that out is you have to figure out what would make the bottom 0. So what I'm going to do is I'm going to take this 2x minus 4, which is just the bottom, right, my denominator, and I'm going to set it equal to 0. Okay, do this with me in your notes. Now I'm going to add 4 and then divide by 2. So x cannot equal 2. That's going to come into play when we talk about the domain of combined functions. Whether we're multiplying, dividing them, whatever, adding them. Okay, most of the time our domain is going to be negative infinity, infinity. There's not a limit. But when we are dividing, there are some values that we cannot have because we cannot end up with 0 in the denominator. So x in this case cannot be 2. It could be negative 2. It could be 220. It could be 2,000. It could be negative 22. It just cannot be 2. Because if it were 2, we would get undefined. We would not get an output. We would not get an answer. Okay? So this is describing the domains. Okay? The domain is the x value that are in both of the domains of g and x. Okay? So if we think about what we could put into f of x, and we think of what we could put in g of x, then the domain of those two combined functions is what the domain of the new function will be. Most of the time, and I know you don't have a spot for this in your notes, most of the time it's going to be negative infinity, infinity. The main exception is when we have division. Okay? Division, you're going to have an excluded value. When we say x cannot equal 2, like on this last one, we're saying our domain could be any number other than 2. Okay, so remember earlier in the year how we talked about negative infinity to infinity. Sometimes there was a limit, right, on some of our graphs where it would start and stop. Okay, well, in this case, most of the time it's going to be negative infinity, infinity, unless it's division. Okay, so here's our first example. And we're going to add. That's the first thing you need to notice is that we have to figure out what operation we're doing. We're going to add these two together. So we're going to put these two together and combine them. So I want you to watch the board first, because I think sometimes we overcomplicate it. Watch the whiteboard. I'm going to literally trace the f of x. Negative x squared plus 3x plus 1. And I'm just going to move it down here and then put parentheses around it. And then I'm going to trace the g of x. And then I'm going to move it down here. And I'm going to put parentheses around it. So the red is my f of x. The green is my g of x. And then what am I going to put between them? Addition. That's it. Which in this case, because there's nothing to distribute, there is nothing right here before the green parenthesis. I don't have anything to distribute, so we can just combine like terms. So I have negative x squared and 2x squared. So that's going to leave me with x squared. Then the 3x I can't combine, so plus 3x. And then I have negative 5, positive 1. So that's going to give me a minus 4. So that's what our combined function would look like. So to put it into like the full function notation, I'll slide that over a little bit. We have f plus g of x equals. So it's just our combined function. That's just telling us that, hey, we took two different functions and put them together. That's all that's telling us. I know it makes it look a lot crazier, but that's all it's telling it. Okay? Now, normally, look up here at the top. When I have like this, f of x equals x squared plus 1, and then I tell you, hey, evaluate the function for this. What are they saying negative 1 is? Negative 1 is what? They're substituting what with negative 1? X, right? Because this is x right here. In this function, this is x. And they're saying, well, instead of x, we're going to say it's negative 1. All this means right here now is that we have our combined function, but now we're going to solve it for 2. So all I'm going to do is take this equation down here, and I'm going to duplicate it. And then everywhere that I see an x, what am I going to put in place? 2. So I'm going to put a 2 right here, and I'm going to put a 2 right here. That's all we did. We just substituted for the variables. Now 2 squared is 4, plus 3 times 2 is 6, minus 4, which is going to give me 6. So we have evaluated f of x plus g of x when x is 2, would be the mathy way to say that. We have evaluated the function for when x is equal to 2. Okay, our domain. Let's think about our domain here. Is there any number that we could not put in here? Like, is there a limit to put in for x? Remember, domain is our x values. Would negative numbers work? Would any of those give us like a no solution or an undefined or something? No. It's all going to work. Okay, even fractional parts are going to work. So our domain is going to be negative, infinity, infinity. Okay, give me a thumb gauge. How are we feeling right there with adding two functions together? Okay. All right. Now let's stay in the same lane, but we're going to subtract now. Negative x squared plus 3x plus 1. I'm going to take that down here. And I'm going to put it in parentheses. 2x squared minus 5. Take that down here. Put it in parentheses. And now I'm going to a minus between. This is the part where I think you can get like tricked. Because you might not apply that negative, that minus sign to the 5. But that is, in fact, negative times a negative. So I'm going to rewrite this below. Negative x squared plus 3x plus 1. And then it's going to be a minus 2x squared because it applies there. But then it also applies here. What's a negative times a negative? Positive 5. Now we just combine like terms. I would like you to go ahead and finish this out. Find what our combined function is, and then evaluate it for x equals 8. Okay, should have that when you go to plug it in. So our final equation is going to be negative 3x squared plus 3x plus 6. Then when we plug it in, we have that. One thing I have to remind you about, and I've done this every class today, is order of operations. We have to do that exponent first. So we have to do 8 squared. That squared is only attached to the 8, not the 3 and the 8. Okay, if it looked like this, and that like all was in the parentheses like that, then it would apply to that whole sum, which would be negative 24, and then you would square that. But in this case, we have to do 8 squared, which is 64, times negative 3, which is negative 192, plus 24 plus 6, which gives us a negative 162 for our answer.
I see now. Okay.
Our domain for this one, again, because we don't have any denominator that's going to mess stuff up, is going to be negative infinity, infinity. Okay, now we're going to multiply. Okay, this does get a little funky. And not funky hard, it's just funky with like a lot going on. Okay, so let's take our first one. 4x squared minus 2x plus 3. Just like that. Then we're going to take our next one. Negative x plus 5. Okay. Now, I want to remind you of something. I'm going to zoom in here quick up top. If I had x minus 3 times x plus 5, what would you do with that?
Do like the
Good, yeah. The FOIL method, okay? The rainbows, this whatever you want to call it. You would go like this, all right? Boom, 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 boom. Okay, that's how we would do that, right? Well, when we do that, we would end up with x squared minus 3x plus 5x minus 15. How many terms did I end up with? 4, right? 1, 2, 3, 4. So I had 2 here and 2 here. So what's 2 times 2? 4. We end up with 4 terms, right? So down here, I've got a trinomial with 3 terms times a binomial with 2. So how many terms am I going to end up with? 6, because 3 times 2 is 6. Here's where it gets a little like crazy because there's going to be a lot going on. We have to distribute this here and here, but then we have to do the same for the negative 2x and the 3. It's just a lot of like mathing, all right? So 4 times negative 1 is going to give me a negative 4. And then x squared times x is x cubed. Now we're going to do the 5. So 4 times 5 is 20, so plus 20. And then there's no x's on the 5, so it's just x squared. Now I'm going to color code this with some different colors. So now I'm doing the negative 2. So negative 2x times negative x gives me a positive 2x. Now we got to take it times the 5, so negative 10x. Oh, there should be a squared on that 2x squared. Any questions so far? Okay, now let's do the 3. So 3 times negative x is going to give me a minus 3x. And then 3 times 5 gives me a plus 15. Okay, do I have 6 terms? 2 blue, 2 pink, 2 purple, right? So that's 6 terms. Now we just combine like terms, like you did back in 7th grade. So negative 4x cubed. How many x squareds do I end up with? Okay, how about x's? Just regular old x's. Negative 13x plus 15. Okay, our domain again. Negative infinity, infinity. Now, if we were to evaluate this for negative 1, where would I put the negative 1 at? Yeah, I'm just going to put it in place of the x's. Okay, this one you have to pay careful attention, because when we're dealing with negative numbers and exponents, we have to make sure that we're taking care to know which sign it should be. Should it end up being a positive or a negative? Okay? So all I'm going to do is copy and paste this black equation down here. And then everywhere that I have an x, I'm going to erase and put a negative 1. Just like that. All right. What's negative 1 cubed going to be? I'm right here. Negative 1 cubed. What's that going to be? That's going to be negative 1, because negative 1 times negative 1 would be positive 1, times another negative 1 would be negative 1. So negative 1 times negative 4 is going to give me a positive 4. Okay, then I've got negative 1 squared. So that's going to give me a positive 1. So it's going to be plus 22. And then negative 13 times negative 1 gives me a plus 13 plus 15. We add those all up, and we get 54. (22 plus 28 is 50, plus 4 more, 54. You guys see where I got to 28? A little mental math for you right there. There you go. I know that these two together are going to make a nice round 50. Another one. Okay, now we're dividing. Okay, the equation part of this might be the easiest. Okay, that's as far as we can go with this. Can't simplify it or anything. Okay, the tricky thing on division is we have to define our domain, right? Because we have a variable in the denominator. So what I'm going to do is I'm going to take that negative x plus 5. And what do I set it equal to? A denominator cannot be what? 0. So now I subtract 5. Subtract 5. Negative x equals negative 5. But I don't want a negative x, I want a positive x, right? So I divide by negative 1. So x equals, or x cannot equal in this case, 5. So x can be 35, it could be 55, it could be negative 5, it could be negative 25, but it cannot be 5. Now if we go plug in the -1, we could evaluate f of x divided by g of x for when x equals -1. So 4 times -1 squared, so that's going to be 1. So 4 times 1 is 4. So I end up with 4 minus, it's actually going to be plus 2 plus 3 over -1 times a negative gives me a +1 plus 5 is what we should end up with. So 4 plus 2 is 6, plus 3 is 9. So I have 9 over 6, which is equal to 3/2.